Hello everyone, welcome to SmartCity, an AI-powered urban waste optimization system that's built using Microsoft Fabric, data agents, Copilot Studio, and Azure Event Hubs. For a long time, urban waste management has struggled with inefficiency, often having overflowing bins in high traffic zones, undercollected areas elsewhere, and unnecessary fuel costs from fixed routes. Our smart waste management project for Dallas City reimagines this process using Microsoft Fabric, data agents, Copilot Studio, and Azure Event Hubs. Through real-time IoT data simulation, predictive intelligence, and automated task orchestration, the system transforms raw sensor data into action, predicting bin fill levels, optimizing collection routes, and assigning tasks directly in Microsoft Planner and Microsoft Teams. This creates a seamless autonomous feedback loop from data to decision to drivers, and therefore achieving measurable efficiency, scalability, and sustainability. And now let us look at where all this begins, the data ingestion layer, where simulated IoT event streams through the Azure Event Hubs into Microsoft Fabric's real-time intelligence environment. And now I'm going to showcase this notebook that is used to simulate bin levels. And you can see that first of all, we have to install a faker. So this is a library that is used to generate synthetic data for simulation, and it helps to create fake but believable information. So we create the random IDs, timestamps, and sensor attributes that mimic real-world IoT data from smart bins. And then down here, we now have the actual notebook that is now used to generate this. You can see that we have the connection string from the event hubs. We are dividing zones, central, north, south, and east. And you can see that below here, we are able to streamline, we are able to simulate those data, and we are now getting the live data that is streaming these events. And now we are going to look how these event hubs look at in Azure.
Our architecture diagram involves us moving the data across Event Hub to Fabric to data agents to Copilot Studio and finally to Teams. So on the Event Hub side of things, we have our SmartCity namespace, which contains two event hubs, the Smart Bins collection and the Smart Bin stream. And as you can see, this is live data as it flows, as you've seen from the notebook. This on the back end, you can see how it's streaming in per minute, and you can see we filtered for, you can have 1 hour, 6 hours, all the way to a month for the request, the messages, and the throughput. So this is what we channel to Fabric. And on Fabric now, we connect the Event Hub with an event stream. So event stream gets to pick the bin logs and all those details from the Event Hub, and then transmit this in real time to our lakehouse, to our event house, and we can now be able to process this data in real time. And you can see the different data we have and the refresh times, because now this is real time and we can use now this data to report.
Next phase is that our data comes to the smart event house in Microsoft Fabric. Here is where we are capturing now the real IoT data streamed from our smart waste bins across the Dallas County. As you can see, the data ingestion here is active with event coming from continuously from multiple bin sensors, and the system automatically compiles and stores this data efficiently for downstream. And the next thing, we store this data in a KQL database. So this now is the KQL database, which is located in the event house. So inside the KQL database, you can explore the raw telemetry received from the bins, and each record, like you can see, it represents, we have the ID, and also we have the timestamp, fill level, temperature, vibration, and location, and other things. So after this, now we get our data to the Power BI, and where we now are able to view the data in a dashboard. So here is the city map. As you can see, it's clustered, but once you zoom in and zoom out, you can locate each bins to the place where it's located. Remember, bins are in every household, in every office. So we have a lot of bins in the city. So this view, you can differentiate between the fill level, the color, the green, you can show that it's partially filled, and also the yellow is moderate, and the red is almost full from above 80. That's why the color is red. So from this, so from here, we have also a list of the each bin and how many times it has been filled. And also here you can see this in this table here. this table shows us the fill each and every day. So you can see for a one or for a particular bin, you can see the way it has been filled. For instance, this bins at 329, it was at 2015 it was 73% fill, but at 2037 it was 82% fill, and later at 2226 it was 87.68 full. So this data is a single data, and you can see even one bin can get filled within a single day, and that data helps us to analyze how often the bins are getting filled, together with the data of how many bins has been filled over the time. You can analyze the data, and then you can make a decision. For instance, if you see that certain bins in certain areas are getting filled faster, you can add more bins so that maybe you reduce the cycles of correction. And also, if there are bins where they are not getting filled, unless they are, you can reduce the number of bins, and then you transfer them to the areas that are getting more bins. So, for instance, now there's what we do. If, for instance, if a driver is given such kind of data and they don't know the location of these bins, if you click here and then you drill through, you get to the bins map, and now this gives you the exact location of that single bins. So using now this, if it's someone who is collecting this, will go directly to this, and then this map give you the view, the direction, and then you can go and collect that bins. And this is just a little about this, because there's more we have added, because even beyond the report, you've integrated a Microsoft Fabric data agent that can interpret this data directly. Now you don't use the reports, you use the data. You can ask questions with your own language, maybe which bins or which zone is predicted to overflow next, and with that you can use AI to make work easier.
So the end result of our project is a Teams app known as Smart Waste, which can be accessible from Teams. And we can start by asking a simple question: which bins are currently 85% full? So it will go to the data source and to the data agent that we connected from Fabric, get those information, and it will be able to give us our results back. We can be able to see that currently there are 25% bins which are over 85% full and are in all the Dallas zones, which are 85% for South Dallas, North Dallas, and 93% for West Dallas. And we went ahead and asked another question: create a collection task for all the full bins today. It went ahead, connected to my planner, and did that. So I'll go ahead to my planner, and you can see these are the tasks that my agent has created, and you can see it's all automatic. No human is needed in the loop. So after which it can be able to notify the drivers to know the routes that they're supposed to take that day. So I went ahead and sent notifications to all the assigned drivers. So it required me to connect with my planner so that I can get a list of all the drivers that have tasks dispatched that day. And how did we achieve this, you may ask? So let's come back to our Fabric workspace. You see, from our data agent that we created, first of all, we started by connecting it to our data sources. So we connected it to two tables, which is the bin logs and the smart bins. And very important, when you create the data sources, it's very important to also give the data source instructions. This enabled our data agent to be aware of what kind of data is connected to it and how it can answer based on those data sources. We went ahead and provided some query examples. So for example, you see what's the average temperature for vibration, and with that we gave a sample query language. This helps our data agent to query this data fast. And another thing is the agent instruction, and in the agent instructions we are able to tell our agent how it's supposed to behave, how it's supposed to answer questions and everything to that. So this is where the magic happens. I went ahead and asked a simple question: what are the historical trends of my data? So our agent went through the data source, and you see that was the response. And this is the cool part. I'm able to see the steps my agent took, the response time it took, and I can be able to see how it analyzed the query it used, which is perfect, and I love it, to be honest. And that's how it was able to come up with all this information, which I really love. And we went ahead and asked some more questions, and it was able to present more responses. After we were confident with our data agent, we went ahead and published it. So gave it the instructions and published it. By publishing it, it was able to appear from our Copilot studio. Now, our Copilot studio is the one which is connected to Teams. So when I asked a simple question, it was able to query the Copilot studio, get the responses from our agent and give the responses back. And you can see also here, I asked a simple question, the same. This is the step that it took. You see, it connected to our SmartWare agent using Fabric and MCP protocol, and that was the result.